Yeah. Can everyone on Zoom hear me? Okay, so let's get started. Can people in the back hear me? Okay, nice. So welcome to the first lab of math and stats in chemical engineering. So this lab section will be teaching you the practical side of the things that we learn in lectures. So we will actually use Python to code them up, and then this will be very helpful in your future career, whether or not you do computational stuff. And before we start, I'll introduce myself. I'm Owen. I had a BS in chemical engineering at the University of Washington. I'm here for PhD, and I'm a second-year PhD in Marquita Landry's group. I do both experimental and computational research. Okay, before we get started, is there any questions on the course? Okay, no question. You can find the lab in the B course file section in the lab. Does everyone have the lab downloaded? Okay, it's okay. Just go to B course and download the files. The B course file lab, and then you can download the Jupyter Notebook. And Yue is our other GSI. He will be helping out in downloading Python. Okay, so let's get started. So this lab, our objective is to install Python and the associated packages that we need and develop familiarity with the Jupyter Notebook interface and understand some basic Python syntax and programming language, as well as implement some basic root finding algorithm using bisection method or Newton's method. So before we start, if you have the notebook downloaded, please complete a survey so that we can know your confidence level in coding. Yes.
You don't have Jupyter downloaded, like, can you go with Jupyter Lab or Jupyter Notebook?
Both works. Yeah. Let's take 3 minutes. Are people able to access the survey, or is there file opening issues?
Feel free to raise your hands if you're ready. So I can Did I watch? Yeah, I mean, yeah. Yeah, it was for 1:30. We just went over like this is regular separable and different code. It wasn't that bad. Yeah, 140 won a little bit more to get in the fast.
All right, so don't worry if you don't have that open, because I forgot we need to install something first. So for people who don't have Python installed, please go to Anaconda. So if you type in Anaconda, the first thing will be the Anaconda distribution. And this will allow us to download Python and its associated packages. So if you click on that link, on the top right, there's a free download button. Click on that button. And then you will need to provide your email address. And then it will send an email to you with the download link. Agree. Okay, and in the email, you can find the download link. Click download now. And then you can choose your own operating system for downloading.
Press download for Mac. Apple Silicon? I'm not really sure. It says 34 minutes, 30, 40. Wow. Oh, mine's up to 1 hour now. I'm at 2 hours. Oh, 3 hours. 2 hours now. I pressed the button. I'm at 5 hours. Oh, nice. I'm at 6. Did you write? Oh, yeah, you're going fast. Okay. Yeah.
Start from 6.
Thanks. Spent $2,000 on a computer. Can't even download. No. Going down. Going down. Mine's barely on 19.
No.
Tomorrow, yeah. That 1:32. No, we'll bring it. It should take like no more than that.
Yeah.
Yeah, remember the 1:30, I'm kind of stuck on the concentration. I did it, but I don't know if it's right. How long is the fun to take? I'm at 7 hours right now. Yeah, me too.
Okay.
We were supposed to click on silicon, Apple Silicon, right?
Both works. Because what's your Mac?
What's my Mac?
Yes. Do you have Apple Silicon? If not, you need to download the Intel chip one.
Maybe that was down.
Okay, so while we're downloading, because downloading local Python installation will be easiest for you to complete your work. So that's why we're doing this. But I'll also show you another way that's much easier, doesn't require any downloading, but you'll need this anyway in the future. So you can go to Google Colab. So type in Google Colab. So what it does is that in your Google Drive, if you drag your Jupyter Notebook in your drive, say I have a Google Drive here. And then in my drive, I will drag the notebook in. And when you double click it, it will go to Jupyter Google Colab. It's an online version of Jupyter Notebook. Yes. So first you open up Google Drive. You drag your file downloaded from B course to your folder. And then you double click to open. It will go to Google Colab. So it will open a similar interface that will allow you to view the notebook. So while we're downloading, are we able to open Google Colab? Yes. That should be.
I just bought the app. There's like an app. Is it what I'm supposed to see? Yeah, because I went to like the app store and I downloaded this
Okay.
Jupyter app, but it was like $3. I don't know.
You need to check the YouTube.
Oh, I don't know. I probably can't.
Does everyone have Google Colab?
Space between the cells.
No. So
Well, I'm rushing right now. Go to upload.
And go to your. Yeah, drag it. Yeah.
Okay, it's uploading.
It should like, it looks like you're just something.
All right, yeah. It works. Thank you.
My computer. But there's an app, you can like buy the app store now. You see the ones who haven't done it. So. Yeah, I don't know that. That's crazy. So like, and it gets, yeah, it's really reliable. Yeah, I get it. So, yeah. I got this one. To get from friends with them. I got. So you together, I calculated all the diet. So, yeah. Oh, yeah, I saw that too, right? Yeah. Wasn't a lot of rice. Yeah, we were like.
We're about 10% done.
Yeah, I remember now.
You can drag it or you can start to.
Oh, so Google Colab, and then just set up like. I don't know why. Yeah, same way that I go to the CBE Google Drive. Well, I guess it. Yeah. Oh, just Google Colab, right? Thank you.
2 hours right
Yeah, that's a few game by and then you know what this attitude.
That's how you get paralyzed from myself.
It's like 5 times already.
I'm at 30 minutes.
You actually.
You're at 11 minutes.
11 minutes? Well, I'm at 8 hours.
Yeah. Yeah, that's another channel.
Well, after.
When that Mac came out, I wanted it so bad because of the low birthday.
Yeah.
Yeah.
You can vote.
Really?
Yeah, the only time I use it is like when I'm just, if I make something.
And I just like.
Yeah, that's okay.
Is that actually work?
It's uploaded on the bit. Like, I like auto play a little bit on my computer.
Mine got 3, don't worry.
No, but super in depth. So you don't even feel like honestly the more he was like lecturing, you know, but
Did you do like?
It's slides. And that I thought was actually that's that I saw there. It was really
Google Colab or any other equivalent opened up. Everyone has the notebook open in some format, right? Okay, then we can proceed with the content. All right, and keep downloading Anaconda for local computing. Okay, so some advice for programming. When we learn programming, Google will be your best friend. If you have problems, there are most likely solutions on the web. And if you're looking for programming problems on the web and you find some solutions, please understand them and then type with your hand your own code. Do not copy and paste. That's plagiarism. You're encouraged to work in groups, but each of you must code individually, and there's no copy and pasting between people. And Python is one of the most popular programming language, and we're using Python version 3. We're using Python because it works across platform. People have Mac, people have Windows, or people have Linux. So we can work across platform, and it has simple syntax, and it's free. We don't have to pay for things. And if you go to work, most likely you'll be using Python instead of, for example, MATLAB. And now machine learning, deep learning is a hot topic. It also uses Python as its language. So that's why we're using Python here. Compared to other programming language, Python syntax is relatively easier, but a thing to note is that it uses new lines and indentations to recommend what are separate commands. So the spacing matters. If you type one more space or one less space, that's gonna screw up your code. So watch that carefully. And to run Python, we can use Jupyter Notebook using Anaconda distribution or Google Colab, which we have set up for everyone. Is that true? Okay, good. And for Jupyter Notebooks, the Markdown syntax, there are different cells. So for example, in Colab, you can have different code cells or text cells. in text cells, you can type things and then you also using markdown syntax. For example, if you want a heading 1, you type a hashtag, and then this is heading 1. Okay, and similarly, heading 2, heading 3, and you can also create links, etc. You can open up a syntax guide to learn more about the markdown syntax, and will also allow you to create mathematical formula, etc. Okay. And then there are some shortcuts that you can learn, I think, in help. Maybe not here. But in Jupyter Notebook, there's help and show keyboard shortcut, and you can learn the shortcut for using Jupyter Notebook or Colab. And you can write mathematical formula inside the cells, and there are some tutorials that we can use, but it's not required for this course. Okay. See. So anyone have questions about the software that we're using? Okay. So let's move on to the introduction to Python syntax. So you can learn more about Python using, well, there are a lot of tutorials online, so you can just search them up, and if you have questions, there will be some answers. The comments are the code that will not be run by the software. It's just for humans to read. And it starts with a pound sign like this. So if you run it, it does nothing. But if you don't have this and you run it, it's an error. So what we do is you can do this comment. Okay. Elementary data types. If we want to represent text, or what they call in programming terms, string, you can wrap the text inside single quotes like this. So some text here. And you have wrap around type around it, it will tell you what type it is. It says str, which stands for string or text. You can also wrap it around double quotes, but you need to be consistent. Single quotes, double quotes, both works. You can enclose double quotes in single quotes, or alternatively enclose single quotes in double quotes. If you really need to, you can use a / key, or it's called the escape key to escape a single quote if you really want to wrap it around single quotes, and similarly for double quotes, but usually not necessary. Besides string, we can also represent numbers, for example, integers or numbers with no decimals. It can be 0, it can be positive numbers, it can also be negative numbers. And if you find its type, it will go return int, which stands for integer. Float are numbers with decimals, also positive, negative, or 0. If you type in the type, it says float, which stands for numbers with decimals. Besides that, we have Boolean types that only have 2 options, true or false. The other one is false. Note the capitalization. If you do lowercase, it will not work. If you do all caps, it doesn't work. So it has to be title case. If you find the type of true or false, it's Boolean. Any questions of the simple data types? Okay. And then we'll move on to more complex ones called sequence data type. We can enclose a list of different elements that we can change order using this type of bracket. So this, a whole thing, is a list. You can enclose whatever you want here. And it can also be mixed type. So for example, we have integer, string, float, could be negative float. This is also a list. And you type it is list. So we use list when we want to change the order in the elements. But if we want the order to keep constant and not change, we'll need to use tuple. It's a list that we cannot change order. So instead of this bracket, we use parentheses. This is a tuple. Okay. And dictionaries are lists of elements with keys and values. So you type in the key followed by a semicolon or colon, and then the value of it, and then comma, keep going with a key and value, and enclose it with brackets like this. And these are dictionaries. In this course, we will be using lists and tuples the most. Any questions on sequence data types?
What do you mean by change order or not change order?
Great question. So for example, we have, actually, I will answer that question later. We will get to that. Yes. And then any other questions? Okay, print statements. If you want to print things or display things, so you can debug or find out the value of something, you can use the print statement. So you enclose the thing that you want to display with print. And then this will print out some output for you. You can, this is for printing strings. You can also print integers. But you cannot print across types. Oh, it can, okay. Okay, variable assignments. So if you want to reuse things again and again, you don't want to type in the same thing again and again. So what we do is to assign variables to things. So variable assignment is used using a equal sign. And the best practice is the first part is your variable name. Usually we use lower cases and lower slash to denote variable names. And then you can type in the thing that you want the variable to represent. If you want to display the variable on the next line in Jupyter Notebook, you type in the same name again, and it will display what you have typed in. So for this example, the variable named my name is assigned to Owen, and you can print my name, and it will display the name. You can also reassign the value of the same variable. And if you watch closely the printing, it prints the new variable assignment, and the old one is lost. You cannot recover. And also note that the variable names are case sensitive. If I type in a capital M, if you print it, you'll see two different variables printed. So it's printing this one and this one. Any questions on print statements and variable assignment? Okay, operators. These are simple math, but we're using it in programming language. So we can do addition with integers will give another integer. But if you do integer and float addition, it will return a float. Similarly, we have subtraction of integer with integer gives integer. Subtraction of integer with float gives a float. Multiplication of integers with integers give integers, and integer with float give float. And division will only give float. And if you encounter an error message, it will tell you what the code is unhappy about. So let's look at how do we look at these type of errors. For example, here I have a string 2 divided by 4. And if you run it, it gives you what's called an type error. And it says unsupported operand types, string and int. So it means that you cannot divide a string or text with an integer, which is expected. What we can do instead is to divide an int with an int or a float with an int. So use error messages wisely. You can also do comparisons in Python. So the double, if you have two equal signs, it tests if the thing on the left is equal to the thing on the right. So is string 1 the same equal to string 1? And it says true, it is equal. But if you ask if string 1 is equal to integer 1, it will get false because it's different types. Similarly, if we can have thing operand that represents not equal to with exclamation equal. So are these two not the same? False, because they are the same. Are these not the same? Yes, they are not the same because they have different types. You can ask if they are greater than, less than, less than or equal to, or greater than or equal to, using these operands. Any questions so far? Okay, logical operators. So true and false are Boolean types, and we can operate Boolean types with these logical operators. For example, if we use and, we need both of the statements to be true to return true. So for example, here, true and true is also true. True and false is false. True or false is true. Okay, these are the and operands. And we can also use or. Or will return true if one of the statement is true. So true or false gives true. False or false gives false. If you're curious, you can also type in true or true to also give you true. So if in doubt, run it out. It's very easy to run commands nowadays compared to 20 years ago. So just try it out. And you can use the not command to flip the true or false. So if it's not true, it's false. If it's not false, it's true. So here are some basic tests. 1 is greater than 2. Is that true? That's false. False. And 3 is less than 4. Is that true? True. That should be true. So false and true is false. So 1 is less than 2. Is that true? That's true. 3 is less than 4. Is that true? That's true. So true or true is true. Why am I doing false? Okay. So this one is more complex. So is 100 integer equal to 100 integer? True. And is 8 integer greater than 0 integer? True. And true gives true. And then not true gives false. Let's say we do 100, is 100 integer equal to 100 string? It's false. And false and true is false. And then not false is true. Okay, you can try it out yourself. Any questions on logical operators? Okay, list. So going back to the list questions, list and tuples, the biggest difference is that we can change elements in the list. And to change that, we need to first access them first. So that goes with list indexing. So this is the biggest warning of this course, is that in list, it starts at 0 for indexing. Usually we count numbers as 1, 2, 3, 4, 5, but Python counts in 0, 1, 2, 3, 4, 5. So 0 in Python corresponds to our 1. Python's 1 corresponds to our 2, etc. So the nth element in Python represents, in our mind, n plus 1. And to define list, you just use bracket. This is an empty list because it has no element. So the length is 0. And this is the example list we have shown earlier. It has a length of 5. And to get element from this list, we can use indexing by using the variable and followed by brackets. And inside the bracket is called index. The index corresponds to the number that Python knows for each element. For example, this element to us is the first element, but to Python, this is the 0th element. So if you index with my list, the 0th element, it gives this. And then you can also try with the first element for Python, that gives is. And etc. If it's second one for Python, it's the third for us. That's 1 to find first. Okay. And something interesting about Python is it allows you to index from the other way around. So if you type -1, that means the last element, false. If you type -2, that means second to last element, that gives true. And -3 gives third to last, gives list. Okay. So now it comes to the reassignment of list. So now let's see what the third element on my list is. The third element for Python is list because 0, 1, 2, 3, that's list. Okay, and if I want to reassign the element with that list, I can use the assignment operator or equal sign and reassign it with a string called this element has been reassigned. And then run it, and we'll see that the list has changed. From list, the third element changed from list to this whole string. If you try it with tuple, let's try it out. If I change it to parentheses, now it's a tuple, and I want to reassign it, it will give me an error. It's because that tuple does not allow list assignment, element assignment. Only list can do that. So if you change it back to list, and then you can do the reassign. So that's the biggest difference. If you want to add elements to the list at the end, you can use the append command. So this is the variable name dot append, and you write your new element. And it adds an element at the end. Any question on list indexing? This will probably be the most important takeaway, is that it starts at 0. If I say multiple times, it might appear in the exam. Not that explicitly, maybe implicit though. Okay, list slicing. We are able to get individual elements from that list, but are we able to get some collection of elements? For example, if I want to get, let's type it out here so we can see what my list is. So here's my list. If I want these two elements, so for human, the second and the third element, how do we get those? We use what's called slicing. So what's this called? Is it semicolon or colon? Semicolon. Okay, so before that, that's semicolon. Okay, that's a colon. So before the colon, you type in the element that you want to start with in Python terms. So I want to start with index 1. So that's 0, 1, start with is. And then after the colon, it's where is ending but not including. So ending but not including. Here it's Python index 3. So 0, 1, 2, 3. And it does not include the 3. So it's 1 and 2. So is and 1. Okay, is that clear? We can try it out with starting at 2 and ending but not including 3. That will only give us 1. And we slice from 3 to 3. That will be starting at 3 and ending but not including 3. So nothing. You can try out from 2 to 6. That will be starting at 2. So 0, 1, 2, just 1. And then ending but not including the 6th element. 1, 2, 3, 4, 5, 6. Oh, because so not including 3. So it will 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. So 6 is not existing. So ending at 6, but not including. So that goes to 5. So that will give this. Okay, 0 means the first one in Python. And if we don't give a number in front, it will automatically assume we want everything at the front. So it will slice up to, but not including 4. So 0, 1, 2, 3, 4. So anything before true will be returned. And then similarly, we have slicing from 4 to the last element. So 0, 1, 2, 3, 4, starting at 4, including the last element, not including the last element. So ending but not including. So that's only true. And if we want to include the last element, just type nothing. Okay, any questions on list slicing? Now, string operations. Strings are very similar to list. because it operates like a list of characters. So we have character T, H, I, S, space, I, S, etc. So if you index the 0th element, that will be character T. The second element will be 0, 1, 2, character I. And you can also use the slicing operation similarly. So starting at index 1, ending but not including index 4, that gives HIS. And then slicing from starting and including 10 to the last one. So ME, interesting text. And this will include slicing from the beginning to the third to the last element. And if you're typing nothing across the colon, that will be returning the everything from the start to the end. Any questions on string indexing and slicing? It's similar to list. And then we can go to F strings. F string stands for format. We can do a variety of formats within F strings. For example, if I want to if I have a variable called my score that's equal to integer 100, and I want to print it out and then have it within a string, this will be the usual syntax. So you have to use a string plus convert the integer to a string and then plus the string. It works, but it's not as elegant. So F string allows you to solve the problem by simply adding an F in front of the quotation mark. And when you want to include a variable outside, you enclose it with these type of brackets. So it will continuously go like, I have scored, and then it sees this bracket, my score, so you plug in the my score here, and then print it out for you. It's just an easier way. Okay. Formatting strings. This is more for making the output more beautiful. So for example, if we want to report a raw result like this and printing with F string, it will give 1 point this many kilograms. But if we think about significant figures, can we really measure to that type of precision? We can't. So what we do is usually report to the lowest number of significant figures, say 3. So if we want to do that, we can use format strings. So after the variable, you type in colon, dot, and then the 2 stands for 2 digits, and F stands for, I think, after the decimal. So after the decimal, I want 2 numbers. So it gives 1.54, and it rounds it for you. Because when you turn it homeworks for what are you guys taking? Process analysis? You don't want to report this. This is an error in significant figures. You want to go through your calculation and see what's the lowest number of significant figures. For example, 2. Then I want here 1 decimal point. I'll give you 1.3 kilograms. So you report that. And if you want no decimal point, 0. And then if you only have without the F, you directly point to, it will give you 2 significant figures. You can also write it in scientific notations. For example, this is 10 to the 5th. And if you add E here, it gives you scientific notation. You can do it with big numbers or small numbers. Any questions? These type of things are usually confusing, so I always Google them when I need them.
So what was the difference between my results, column dot 2 versus the 2F? Is it just the same thing?
So 2 and 2F, the difference is that 2 gives you 2 significant figures, 1.5. If it's 2F, it gives you after the decimal point 2. Yes. Great question. Right. Moving on to functions. Any questions before we move on? Okay. Functions. If we think about functions in the context of our course, we think of mathematical functions. And in Python, we call them lambda functions. I don't know why lambda, but they just call it that. And we use it if we don't want to really name the function. So for example, the function syntax, if we want to have a f of x equals to x squared, it will go like f is the function name, is assigned to a lambda function with variable x, and then colon is a syntax, colon x squared. This will define a quadratic function for you. So think it as, usually in math terms, we have f of x equals to x squared. Think as the f as the name being assigned to lambda, x is the variable name. And then after the colon is the content of your mathematical equation, but in Python terms. If you type in this caret thing, it will not work because Python recognizes 2 stars as power. So this gives you a quadratic function. So for example, the quadratic function evaluated at 0 gives you 0. Evaluated at 2 gives you 4. Evaluated at 4 gives you 16. So let's try to see if we use carets instead of Python's syntax, what will it give us? The function is defined, but if you run it, oh, it works? What? Okay. Never mind. Okay, so if we want to make it a cubic function, we can change it to 3. And as you expected, it will change to 2 to the third, 4 to the third. You can also do square root 0.5. Like that. Okay. So here is another example of defining polynomial functions. That's 1 minus x squared plus 5x. And you can evaluate it at different numbers. Find it first. And then, for example, if we can also take the derivative of it and calculate, the derivative should be minus 2x plus 5. So I do y here is because I use the y as a variable. So this basically gives g of y is equal to minus 2y plus 5. And you can evaluate it at different numbers. Any questions on lambda functions? If you have something that's more complicated than a mathematical formula, we will need regular functions. And the syntax is a little bit more complicated. The syntax goes with def, standing for define, and a space that follows with your function name. And within the parentheses, you can have different arguments, or in our case, it's f of x. So the x is an argument. And within that function, you can do anything you want, basically. And then the return syntax will ask you, what does the function give you out? So this function gives you nothing. It returns blank things. So if we run it, it will only print the first argument and the second argument. So this is the definition of function. And if we want to run function, we call this, we're calling this function. And we're calling the function, my function name, with argument 1 as something 1, argument 2 as false. What it will do is run line by line. So first line is a comment. It doesn't do anything. The second line goes print argument 1 and argument 2. So if you run this, it will print something 1 followed by false. And you can similarly do this. The function name is quadratic, variable name is z, and it is returning z squared. And it will return, you can call it at different numbers. But be aware that you have to have something that's returning in order to let it return something. If you say here, result is equal to z squared and return blank, if you run it, you will return none because you're returning nothing. So if you have a result here, make sure you return the result so that you get the result back. And then here you has a complicated operation. So here we have shown the simple ones, but we can have very complicated mathematical operations here. For example, we're taking the function name is complicated operation, taking in arguments called input 1, input 2, input 3. And we're doing divisions, additions, multiplications, and the result is a whole combination of them. And then we're returning the result. And we can run that, and the function runs. Or we can add strings together like this. Any questions? Okay. Range functions. If you don't know what the function means, you can add a question mark and then run it in your notebook. And it will return the documentation string for you. So it takes some argument. So the first argument, if you only input one argument, it's the index that it will stop at. So the range of 2 gives you 0 and 1. The range of 4 gives you 0, 1, 2, 3. So it stops at 4. Stops but not including 4. And it defaults to start at 0. But if you include the starting position, you can control where you start. For example, the range of 1 to 3, it's starting at 1, ending but not including 3. So list will be 1 and 2. And you can do a whole range of things. For example, the third argument is the step. So here it says, I want the range starting from 1, ending but not including 3 at a step of 2. So it go from 1 to 3, 5, etc. to 33. Because the next one, if you add 2, it's 35, but it does not include 35. But similarly, I can do starting at 1, stop but not including 34 at an increment of 2. So 1, 3, etc. to 33. If I plus 2, that's 35, but that's beyond the range. So these two returns the same thing. Any questions on range functions or functions? Okay, now programming logic. We have if, else if, and else statements. So if statements will run the thing that's below the if statement if the statement gives true. So if true, it will run this. But if it's false, it does not run. But usually we will put a conditional statement here. So if 3 is less than 4, we print this, so it prints. But if 3 is greater than 4, which is never true, so it's if false, it will not print this. So we'll print, it will not run this code. That's simple if statement. Can also have an else statement. So if the true part does not run, it will run the false part. So if true, it runs print branch A is true. And the else part is discarded. It does not run the else part. But if false, it does not run the first part and it defaults to the else part. So the return statement is branch B is reached. You can also have else if situations so that if true, it will print this, and then that's the end. And then here as well, if true, it doesn't look beyond. So then after it prints, it's done. But if you have an if false, this line will not be run, and then it will look at else if this is true, it will print this branch. So the result is branch B, and then it moves on without looking at the else statement. If the if statement and the else statement is both false, it will print the else statement. And you can have multiple else if statements. So here, if false, so it doesn't run, else if false doesn't run, else if true, so it only runs this part. So it returns branch C is true. Pass statement does nothing. So even if this is true, when it reaches here, it simply does nothing. This could be useful if you're drafting a function and don't want to raise an error within the function. And here, if false, because this is false, this doesn't run. So it defaults to else. And then the else statement is pass, so it does nothing. Any questions on if, else statements? Loops. There are two types of loops. There are for loops and while loops. For loops is used when you have anticipated number of loops, and while statement is when you don't. Okay, yeah. Be careful about the indentation. So when we're doing loops and if-else statements, there's an indentation that you need to keep the spacing consistent. So you can use tabs or space, but just be consistent. For example, here we have what's this? This is a list of different elements. And then we can assign a variable called element. So for each element in this list, I will print the element. So it will go through this list and print each of these elements. So this is element 1, sum, element 2, element 3 in human terms, 4, 5, 6, 7, 8, and we'll print everything. And of course, we don't want a whole list to be here, so we can assign a variable to the list. So we call this list my list, and then for element in my list, so it goes to this thing. So 0th element for Python, first, second, third, fourth, it will print all the elements. Okay, any questions here? Yes.
Label this as a variable in my list.
Yes. Yeah. So usually we don't really put the list here. Usually we will define it earlier. So I'm showing that we can use some variable that is pointing at this list and use it for looping purposes. Great question. And this is more complex. So enumerate. So when enumerating a list, it will generate the index and the element. So what it's printing is that at index 0, the element is called sum. At index 1, the element is called interesting. At index 2, the element is called list, etc. So if you want to have the index and the element at the same time, you can use the enumerate command. Okay. And this is a review of the range function. So range of 5 gives 0, 1, 2, 3, 4, because it stops and not including 5. So this will, for element in range 5, it will print from 0 to 4. This is a more complex one, starting at 2, ending but not including 25 at a step of 5. So it will print numbers 2, 7 to 22. And here is how we use enumerate. If we want the element of the list and the index, so we can define the index and the element. So it's the 0th element is 2, first element is 7, second element is 12, etc. Any question for loops? Okay, while loops is when we don't know when we will stop. So when using while loops, there is a danger called infinite loop. So while it is true, we'll do something. So let's say we print 0. And because true is always true, it's not updating. It will always be printing something. See, it's printing 0 nonstop. This is called an infinite loop. And when you encounter an infinite loop, you'll see that it's always running and you can't run anything else. To break it out, you need to click the stop button here to end the command, to break out the infinite loop. I hope it can break out. If it doesn't, I need to restart this notebook. Okay, so do not do infinite loops. Okay. Okay, yeah, this is giving an exception that I'm doing an infinite loop, which is not good. Okay, so when we are using while loops, we must be careful of not stepping into infinite loop. And we do that by using counters. Okay, we need to first establish a counter. For example, here, the counter is initialized to 1. And while the counter is smaller or equal to 20, it will run these commands. So, and then we have counter is updated with a counter multiplied by 2. So initially it's 1. And then while counter 1 is smaller than 20, which is true, it runs. So counter is updated to counter times 2, which is 1 times 2 is 2. And it prints the counter, prints 2. And then it goes to another loop. And now counter is 2. Is 2 smaller or equal to 20? True. And it runs. So counter is reassigned to 2 times 2, 4, print 4. And then rerun. 4, is it less than 20? Yes. Then 4 times 2, 8, print 8. Loop, 8 is smaller or equal to 20? Yes. And then update 2 times 8, 16, etc. And it stops when the counter is not less than or equal to 20. So it's important that we initialize some sort of counter, but keep updating the counter so that we don't fall into infinite loops. And the order of the commands do matter. So say let's switch the order of these 2 commands. The result will be different because here, the first one, we have counter going in. We update the counter first, then print. So this is printing updated counter. But here we're printing it first and then updating. So the order matters within the loop. Continue statement. If you are inside the loop, and if you want to stop the loop temporarily, you want to use the continue statement. So for I in range 7, so what's range 7? It goes from 0, 1, 2, 3, 4, 5, 6. Stop and not including 7. Okay, so this is list range 7. And then within that, it says if I is equal to 4, so the first one is 0. Is I equal 0 equals to 4? No. So it passes. It prints I. And it loops 1, 2, 3, 4. When it runs to I equals to 4, 4 is equal to 4. So that's true. If true, continue. When continues, it breaks the loop without running the print statement. So it goes back to the for loop with the next one. So 5. 5 is not equal to 4, so print. So if you look at the outputs, 0, 1, 2, 3, 5, and 6. There's no 4. So continue breaks the loop by going back to the start of the loop. And similarly, if you do it's not 4, it will only print 4. Yes.
Sorry, on the previous one with the counter, is it common to, do we start the counter at 0 or at 1? Or does it matter?
It does not matter. It will depend on the purpose of our code.
How does it know what I is? Where do we initialize I before we start?
That's a great question. So I is called an iteration variable. So it's defined, so the name is defined as I here. So the first variable assignment is the first element of the list or tuple or anything that's able to iterate. So we automatically assign. So for I in range this. So it assigns I as 0, the first element. And when it runs the loop again, it will assign to the other, set the next element, etc. Great question. So you don't need to define I beforehand if it's an iteration variable. Any other questions for loops? Continue statement. So in contrast to continue statement, which breaks the loop and go back to the start of the loop, we have break statements that just crashes the loop. When it hits break, you're outside the loop. You don't go back. So for example, here we define I is equal to 0, and while true is an infinite loop, but print I, and we update I with plus equal 1. That means that it's I is equal to, this is equivalent to I is equal to I plus 1. So it's updating itself. So when I is reached to 6, it will break, meaning that the whole loop is being broken instead of going back. So if I run this instead of an infinite loop, it will stop at 6. Any questions on continuous statements, break statements, loops. Okay, now we have completed the basic Python syntax. And now it's the numerical method part. So we're using computers. And when we're studying mathematics in lectures, we're used to continuous analytic expressions. But computers doesn't work in continuous ways because it's all binary. It's all 0 and 1s. So computer, instead of continuous, it's discrete. So the biggest difference in calculating analytical expression in lecture and in numerical methods using computer is that we have something that's called the smallest increment that we can represent on computer. And the smallest increment for Python, regular Python float, is 10 to the negative 16. And we can illustrate that with this. If we have a big number that's 1 and a small number that's 10 to the negative 15, denoted with 10e minus 15. If we add those, we can still see that minus 15 because it's bigger than the smallest increment. If we're barely above it, we can still see it, but we're at the smallest increment. If we add them together, Python will not recognize it because it stores up to 10 to the minus 16. So 16 digits afterwards. If you have 10 to the 17th, minus 17th, it doesn't store. And the error in such calculation caused by the rounding at that 10 to the minus 16 is called a floating point error. And does that error matter to us? Will be depending on the purpose that we're using. If we're doing supercomputer calculations for weather model, climate change modeling, then it might matter. But for our course, if we're looking for a rough approximation for engineering purposes, we're rounding to significant figures anyways, it will matter less to us. So here's a problem. When calculating the mass of benzene needed to feed a reactor, computer A gives you this and computer B gives you this. Which one do you trust most? And how would you report your result? So I will say both would be trustworthy because order of magnitude wise, they are really similar. And computer B is giving you all the rounding of the decimal points. And when reporting the result, you will want to report to the lowest significant figure. So if the lowest significant figure number is 2, you will round it to 1.2, but not reporting everything here. So if you copy and paste this to your process analysis class, that will be a deduction of points, I think. Okay, any questions on numerical methods and the difference with analytic expressions? And we'll see this more in the next lab when we graph things. We'll see that doesn't matter if things are discrete and we're plotting the continuous thing, doesn't matter. But for now, let's move on with practices of Python syntax and illustration of the discreteness of computer using root finding algorithms. So root finding algorithm basically has the following problem. If we have some function f of x, we want to find x such that the function is equal to 0. Well, you will be thinking, well, that's not so useful if it only gets 0. But we can transform the problem such that we can find any value. For example, it will be useful for find when x equals to any values, when the function value is equal to any value c, a constant, then it is equivalent to a root finding problem such that f of x minus c equals to 0. And we can call this a g of x, another function. So it returns to the root finding problem. So basically, with this algorithm, you are able to find the x at which the function equals to some particular number. And one of the most basic method is the bisection method. So if we are given an interval, we're finding the root. And the intermediate values theorem states that if for a continuous function, if two function values have opposite signs, they must cross 0 at some point. If you cross from negative to positive, you have to cross 0. So that's why we can use root finding algorithm. To illustrate this, the easiest way to think about this is that, say we have this table here, that's this length, and my phone is here. And we want to find where my phone is without looking. And you can only try this increment at a time. You can't be like touching everywhere. So how do you find it the easiest? So you bisect it and then see, well, it's in the middle. You ask, is it in this range or is it in this range? It's not in here, so I only look here. And I bisect it again. Is it on my left or on my right? It's on my left. So I keep it in this range. And then I bisect more, it's in this range, bisect more, and then find my phone. That's the algorithm, how it works. So we want to define the left boundary, a right boundary, and the middle point. And when we're doing that, if the middle point and the left boundary have opposite signs, then it must cross 0. So we will change the interval to that. Or if the middle point and the right boundary have opposite signs, meaning that it crosses 0 in that interval, we will change the interval to that smaller one. And here's a guided problem of how do we implement that algorithm. So for a given function f of x, a polynomial function, let's first solve it analytically. So going through basic algebra, we will find that the solution is x equals to 1. And so also plus or minus square root of 2. And I will also want to introduce you some other methods. We don't just want to learn programming, but also useful things that will be very helpful for your chemical engineering core classes. For example, Desmos is an online calculator. So what we can do is to also find root using Desmos. So what we want to do is to input the function here. So x to the third. I think you can see my keystrokes here. So what I type is x to the third plus x to the second minus 2x minus 2. Okay, so this is the functions graph. And we can find the root pretty easily by just clicking on. So it's consistent. Well, it's not consistent. This is wrong. So this should be -1. Great job. Okay, so -1 plus or minus square root of 2. Okay, and we can similarly use Wolfram alpha. So what we do with that is that we similarly type in x to the third plus x to the second minus 2x minus 2. And it gives the graph and then gives you the roots. So if you want to find it numerically and you don't want to program it yourself, relegate to some other calculator. And now let's try finding the root numerically using the bisection method and consider the numerical tolerance and maximum number of iterations allowed. Okay, so what we do here is that we want to think about what we want to define. So the problem here is we have a function, so we want to define that function. So to define that function, we can use what we just learned, the lambda function. So let's call that f. So f equals to lambda variable x. And the function is x to the third. Remember, Python syntax uses 2 stars for raised to the power. To the 2 minus 2 times x minus 2. So that defines our function f. Okay. And then what do we want? We want to find the roots. So we want to find some boundary. We want to define the left bound and the right bound. So let's say the left boundary, since we already know the solution, we can cheat a little bit. So let's find the positive one. So let the left boundary be 0 and let the initial right boundary to be, say, 2. Okay. You can run it and you can verify if they're actually 0 and 2 if you want. Okay. And important thing about numerical algorithm is that we can only get to the solution at a finite amount of closeness. We cannot get the exact solution because we have that lowest number of tolerance, 10 to the negative 16. So we need to set some numerical tolerance and of our choosing. Maybe as an engineer, you could decide, well, maybe 10 to the negative 6 is close enough for my homework problem. And that will be my numerical tolerance. And if we want to make some loops, we will also need to define some maximum number of iterations so it doesn't run into an infinite loop. For example, 10,000 times. Okay, I'll put them into the same cell. So we define the function, left bound, right bound, and these two are for numerical methods. And what we want to do is to calculate. If we look at the algorithm, we want to calculate the function evaluated at the midpoint and the endpoint. So let's say we evaluate the function f at the midpoint. So this is the function name, f mid, is equal to, I evaluate the function at some middle point. Okay, and the middle point needs to be defined initially. And how do we find the middle point? We define the left boundary, we define the right boundary, we cut it in half. So we just find left plus right divided by 2. That will be the middle point. So we want to evaluate at the middle. Okay, so let's run this. So it doesn't give a value because we haven't printed them. So mid is 1. F mid is -2. And we can similarly run as f of left and f of right. And you can immediately see f middle has the same sign as f left, both negative. So we're not guaranteed that it will cross 0 there. But when we look at middle and right, we have a negative sign and a positive sign. So it's guaranteed to cross 0 in that interval. So what we want to do is to change the interval to the middle point to the right point. So we want to update the left boundary to the middle. Okay. So let's see. How do we do that? So we want f right equal to right, and then f left to be f evaluated left. Okay. And so if we find that the f mid is equal to 0, then we already found the answer. If it's not 0, we need to keep doing the algorithm. So if f mid is already equal to 0, we can print the x because that's already the answer. But if it's not equal to 0, we need to do the updating. And how do we update? We need to recognize what signs are changed and what are not. So when we're comparing the signs between middle and left, how do we compare them? So if they are different, it crosses 0. If they are the same, it does not necessarily cross 0. So when they are different, when we multiply them, they should be a negative sign. When they're the same, when we multiply them, it should be a positive sign. You follow? Okay. So here we have negative times negative should be positive. Positive is same sign. So if the boundary f mid times f left is positive, meaning that they have the same sign, we want to update to the right. instead. So we will assign, so left min and it's bigger than 0 have the same sign. So that means the right boundary has the 0. And we want to update the what boundary? Let's think. We have an interval. Okay. And then we calculate the middle point. Left, mid, and right. When it crosses, this is 0. This will be negative. This will be positive. If we multiply f middle, which is negative, with f positive, so f right, which is a positive sign, it will give me something that's negative. So if we have that, we want to move the boundary to the right. Okay, so we want to move the left boundary as the middle. So what we want to do is to assign left to be middle. And alternatively, if the opposite is true, if we multiply left, f of left with f of mid, we find it's minus. Then we want to move the right to the middle one, and shrink it to that. Okay. The process of using diagrams and this type of thinking is called pseudocode. When you can't just stare at the code, you need some reference. So we're looking at when they are negative, so less than 0. When middle times, okay, let's do this first. When middle times f of right first, when it's negative, it has opposite sign, meaning that it has crossed 0. We want to update the left boundary to be the middle one. So let left be assigned to mid. Okay, and the other case would be if we multiply the middle, f mid, multiplied by f left is smaller than 0. Then we update right to be middle point. Okay, any questions? That's the basic logic, but we don't want to just use if statements. So here we have if, and these are mutually exclusive. If we have this, we'll break out. It's already done. If it's not done, it's elif. It's not this, elif this, and then I'll add an else statement. Okay. So this is for one step. So 1 iterations of finding the boundary. And we want to do multiple of them. So if we find it here, so we change here. So now this is iteration 1. So iteration 2, now here is left. So we bisect to the middle. This is the middle one. And then compare again. And we find out we use this one. And then we keep going. This will be the left. Go to the middle. We see that this crosses. So we use this interval. So we need a lot of iterations to complete that. And to do iterations, we need loops. So in this case, we can do a while loop. Okay, so this is the programming logic for 1 iteration. So let's write the loop. So while something, how do we replace this? So when it's not at our numerical tolerance, when it's not close enough to our answer, we want to keep doing it. So when the tolerance is less than how much? So when the error is less than the tolerance, so we want to calculate the error between the current function value at the middle point and compare it with 0. So when the function f mid is bigger than tolerance, we will keep doing that. But f mid could be negative or positive, so we want to do an absolute value of that. So that's the first condition. When we're comparing the error with the tolerance, is it small enough? If it's small enough, we accept it. As if it's not small enough, we continue to do that. And to avoid infinite loop, we want to have the maximum iteration counter. So we want to set up an iteration counter, say I, so I equals to 0. If I is smaller than the maximum iteration, we keep going. If it's reached maximum iteration, we stop because we don't want an infinite loop. So that's the two conditions. Checking for error, is it done? And checking if we have reached maximum iteration. And for each iteration, we want to put our logic in, right? So I'll just cut and paste indentations. Okay, and within that loop, we want to update the value of f mid so that we want this all to be updated. So we put that in too. Okay. Anything else? So tempting to run it. Okay, so that gives you an error. So that's good because we know what's wrong. So f mid is not defined initially. So we need to define an f mid initially. So let's, because we want it to be above the tolerance, we can define anything that's above the tolerance. So let's say tolerance times 2. So it's guaranteed to be bigger than the tolerance. Okay, let's run it again. So it's running. Okay, running. So that's not good. There's some error within it. So we need to check what's the error. So I think it will stop when it reaches the maximum iteration. Hopefully. Oh, it doesn't. Do you know why?
Somebody else said it.
Okay. Okay. It's running infinitely because we have a counter, but we don't update the counter. So I is always 0. So it's always below the maximum iteration. So basically, this is not achieved, and this is true, and this is true. So it keeps running. So what we do is to break it out. And at the end, we need to update our counter. So I equals to I plus 1. Okay, now it stops. Good. So let's check what's the I. Did it reach? Okay, it reached the maximum iteration. So it means that the algorithm didn't really find the root. We can check what's the x now? What's the midpoint? So the midpoint is 1.14. So that's square root of 2, so it did work. It's just haven't reached our numerical tolerance of 10 to the negative 6. Okay, any questions of this? Yes.
It seems like that number is like smaller than 10 to the negative, or more precise than 10 to the negative 6.
That's, let's see. So let's see what's this tolerance. So this process is called debugging. So if you think it's wrong, we can just print things out and see what's wrong. So here we have the absolute value of f min is 2 times 10 to the negative 6. So it's still above the tolerance. Okay. Yeah, we can verify that with numpy square root of 2. Okay, important. This is beyond the scope of this lab, but we'll introduce it next lab. So square root of 2 minus mid. Yeah, it is more precise for some reason. But okay. So this is, I think, expected behavior. And if you're curious, you can run the, yeah. Oh, min. Great catch. Thank you. Thank you. Where did I define minimum? Okay, that's sad. So it should be a middle, not minimum. So this should be mid. Great catch. Thank you. That's a good debugging. So now let's try. I is 1, so it reaches at the first one. Okay, because we need to rerun this. So it stops at the 22nd iteration, and the result is this. Okay, nice. Thank you. And as I coded this live, it's a little bit weird, but you can look at the solution to look at the step-by-step with comments. So since you have seen me code, we don't code linearly like this. We are doing some inner logic and then outer logic. And then if there's bugs like a typo, we need to recognize that too. So that's basically the process of coding, sadly. Okay, there's a 5th problem. Is the bisection method result consistent with your analytic, graphical, and symbolic solutions? So the first one is analytic solution. The second one is graphical solution. And the third one is symbolic solution. So is your result from this consistent with those? Yes, no, maybe. So partially, yes. So these type of root finding algorithm will only enable you to find a root, but it doesn't guarantee to find all roots. So I showcase here a polynomial function with 3 roots. So it has 3 roots, 2 negative and 1 positive, but we only found the positive one. So the limitation of these type of method is that you need to define your boundaries carefully. And you can only find solutions within that boundary. So maybe say, let's do -10 to +10. So it will bisect to one of the solution, but you can't find it all. So you need to find it carefully. So that's the caution here. You can practice with the practice problem, mostly copy and pasting, but you need to change things carefully. Okay. And we also have another method called the Newton's method, which also used for finding roots. I think this is covered in calculus class. Yes, no? If not, the algorithm is here. So we're basically using a tangent line approximation to look at the formula. And then there's the derivation and the result. Basically, this line is the programming logic that we will need. And you can practice coding this up with the function. There's some hints about what you need. For example, functions, the derivative of that function. So we need to solve the derivative of this. Some initial guess, iteration counters, numerical tolerance, and the maximum number of iterations. Okay, is there any questions? Okay, so let me know if you have questions. And I have office hour Mondays if you need me. And before we go, submission. So the lab is not graded, but we want you to complete it. So it's a completion grade. So if you attempt it, upload it to Gradescope, that's good participation. And also please fill out the survey. And the survey will also be a part of the participation as well. And also a great way to give me feedback. Is it too fast, too slow? Is it confusing? Is the things that you're learning not aligning with your future use in career? That sort of thing, so we can improve the curriculum and make this maximum use for you. Okay, and please upload this to Gradescope if you complete it. Oh, another thing I'll show you. So after you save it, you have a Jupyter Notebook, but usually we want to save it as other forms because you've seen I made a mistake of letting you to open a Jupyter Notebook without having Jupyter Notebook installed. So you can save and export using different formats in files, save and export. So what I usually do personally is export to HTML. That gives like a web page type of thing. And after you have this web page, you can't just submit web pages to your instructor, right? So you can print the web page. And then when printing it, it's saved as a PDF. And you can upload that PDF along with your Jupyter Notebook to Gradescope. Okay. All right, yes. So you have a week to complete this lab. So beginning of next Tuesday, 12. And
Do we have to complete the practice problem or?
the
Oh.
practice.
There will be one or two suitable vetting policies below. So, it's better to.
Okay, that's all for this week. Let me know if you have questions and looking forward to see you next week.
What the big download? I'm not so for the next.
Yes.
Thank you.
Yeah, this
Okay. Mine's kind of long. I was like getting some visions out.
we can also do it like the thing that by minutes of the focus and I will
So it's I think it's better. I can put it in the past.
yeah, so on order 1, 2, 3.
Yeah, okay. My question, better like what lines this is what I'm going to use like
So you'll need to do practice problems when you label and there will be code cells that you can and you need more code cells.
I'm going to have all the cards on Monday.
Yes, I will have it office on Monday. It's on the syllabus. And I think it's
Okay, now and what is the like I saw the assignment of the temper homework. What is the relationship?
in this class. Okay, so the homework is mostly analytical, right?
Or should we use a coding or system?
It's different and it won't in later stages. It will happen on
This one is not credit. I mean, you're credit. This is just part of the practice.
This
Yeah, the whole.
may be on the exam, but it will not be. Please take the code. We will do a much easier version to test your understanding.
Okay, thank you. Okay, I'll see you.
I tried exporting the Jupyter Notebook file and it didn't work. So I'm trying to bring that to them.
Yes.
Why does it only print one page?
Oh, okay. Good question. So think because you need it for- let's see what's the.
I tried exploring, yeah.
Is it 403?
I tried PDF.
Oh, PDF sometimes it doesn't work. So
Oh,
that's
the
why I
PDF.
specifically recommend. HTML.
Oh,
Then-
and then printed,
Yes,
like print HTML.
Yep. this will print all the pages.
God. Oh, I see. Yeah, cool. Thank you. That's all my question.
Yeah, sometimes the installation has some
Right.
problems.
Oh, actually, also, is there like an online version for this, or this is for another lab? Just like they will just participate.
So we have Monday and Tuesday. Monday is Labor Day.
Right.
So that's why we have a Zoom.
Okay, but usually they wouldn't be. All right. Cool. Thank you.
I don't, I'm okay, when they go for the, that's pretty fun.
So if you scroll down and then come into. and click launch. And then when launching, it will go to your browser. It opens up in your browser. Okay. And this will be in your root folder, and you'll need to find your Jupyter Notebook. So you need to from here find the next question mark. Oh, homework. I'm sorry, I'm not responsible for homework, so I'm not really so much useful.
Oh, okay. Okay.
Yes, so. When we do this. And infinitely, the right results. But because of the discreteness of computers, will require only something like. Exactly, it's probably set. Are we able to accept?
Yeah.
Or does.
Let's see if it's good or not, because if it's good, I'll just be serious.
Of course, it's good.
We're not
Yeah.
done yet, come on. Come on, guys. We just need to until.
It's just a minimize the value that you find. We define it as foreign. He wants to.
No, it's not.
We want it to apply. That's just we could make this an outfit. But I just find
No, she's old.
doing it's either to the either to the right, either to the but if there is a program here, I don't know that. That's
Those
what
people are older than we.
it's like, if you want to wait for one, you can hang out here. If I want, for example, if I bought this computer, I can only.
Yeah, yeah.
This is all my data. Always like that. Yeah.
I'm gonna do this. Yeah, no worries.
Yeah.